Solving systems of linear equations by graphing. All right, so here's your standards like always. To be successful, you need to be able to determine whether an ordered pair is a solution of a system. You need to be able to graph a linear system and approximate the solution of a linear system using a graph. The vocabulary that you need to know for this lesson: system of linear equations is a set of two or more linear equations in the same variables. A solution of a system of linear equations in two variables is an ordered pair that is a solution of each equation in the system. So that's important. To be a solution, the ordered pair has to be a solution to both equations. If it's two equations or three equations, it would have to be a solution for all three equations. All right, key idea. Solving a system of linear equations by graphing. These are three steps that you can use in order to make sure you are successful. First, you would graph each equation in the same coordinate plane, estimate the point of intersection, and check the point from step 2 by substituting for x and y in each equation of the original equation. All right, so it says estimate the point of intersection. If you graph your equations in the same coordinate plane, the intersection point would be the solution. All right, example 1, checking solutions. Tell whether the ordered pair is a solution of the system of linear equations. All right, so you can see for part A, we're given 1, 2 equations, and we're given an ordered pair. So they simply want us to see if this ordered pair is a solution to this system. So all we're going to do is substitute that in. So the first equation says x plus y, so my x is 2 plus 5. Does that equal 7? And yes, that does. So 2 and 5 is the solution for the first equation. So let's check the second equation. Let's see, my pen is not working too well. Give me just a second here. All right, so we've got 2 times x, x is 2, and then minus 3, y is 5. You know that this is your x and y right here. That's what we're doing, checking this point to see if it's a solution. All right, so that's going to be 4 minus 15. Does 4 minus 15 equal negative 11? Negative 11 equals negative 11, so it does. So 2 plus 5 equals 7. And when we plug in 2 and 5 in the second equation, negative 11 equals negative 11. So we can say that 2, 5 is a solution to this system because it works for both equations. All right, let's do example B. Take a moment, see if you can do this. Go ahead and pause the video. Once you have time to substitute your x and y into both equations, check it. Come back and see if you did it correctly. All right, the first equation says y equals negative 2x minus 4. We know that this is our x and this is our y, so we can substitute 0 in for y. Negative 2 times x, x is negative 2, minus 4. So does this create a true statement? Negative 2 times negative 2 is positive 4. 4 minus 4 is 0. 0 equals 0. So it does work for the first one. All right, let's check the second equation. Y equals x plus 4. Again, our y is 0. Our x is negative 2. And negative 2 plus 4 is 2. 2 does not equal 0. So this one is not a solution. So this ordered pair is a solution to the first equation, but it's not a solution to the system because in order to be a solution to the system, it has to make both equations true. All right, self-assessment. You should take a few moments and see if you can answer these. So just pause the video and then come back when you have your answers and we will check it. All right, I'm hoping that you took a few moments and plugged these in and tried to see if you could answer this. All right, the first one says one equation in a linear system is 1/2 x plus y equals 1. Is it possible for the system to have a solution of 0, 0? All right, so I plugged in 0, 0 to my equation, and 0 plus 0 does not equal 1. So 0, 0 is not a solution. All right, then it asks about 100 and negative 49. Plug in 100 for x, negative 49 for y. 50 minus 49 equals 1. 1 equals 1, so 100 and negative 49 is a solution because when I plugged in the ordered pair, it gives us a true statement. This one gave us a false statement, so it is not a solution. All right, open-ended. This one says write a system of equations that has a solution of -1, -3. All right, open-ended means you can write any equation that you want as long as when you plug this in, it creates a true statement. All right, the easiest way to create a system of equations would be like, this is your x, this is your y. You can do something like x plus y equals what? X minus y equals what? Using these as your x and y, you can very easily and quickly create two equations that produces this as a solution. Example 2, solving a system of linear equations by graphing. All right, so to solve by graphing it, we're going to have to graph both equations, and then we're going to have to look for the intersection point. Once we find the intersection point, we're going to take that point, we're going to substitute the values in both equations to make sure it's true. So let's go ahead and look at both equations. Let's graph the first one in red. All right, we're going to graph this one in red. So this is your slope, this is your y-intercept. So we're going to go up 1, 2, 3, 4, 5. Start with putting a point on your y-intercept, then use your slope to find another point. So your rise over run, rise -2, run 1, -2, 1, -2, 1. So you can go in both directions as far as you need. Let's go ahead and try to graph a line here. Okay, now let's look at the second line. Let's put this one in blue. All right, so this one has a slope of 4 and a y-intercept of -1. So come down, let's put a point at -1 on your y-axis. All right, and we have a slope of 4, so rise 4, 1, 2, 3, 4, run 1. Right there's going to be our intersection point. So we're going to rise 1, 2, 3, 4, run 1. All right, so we're going to graph this equation as well. All right, and hopefully you can see easily that this is the intersection point. So let's check our point. We want to always make sure that we check our point. So I'm going to come back here. Let's just get my black pen again. And this would be the point. So this is over 1, up 1, 2, 3. So this looks like 1, 3. So that looks like our point of intersection. Let's check to see if that works. Okay, so remember this is our x, this is our y. So our y, look at the first equation, our y is 3 equals -2 times x is 1 and then plus 5. So does 3 equal negative 2 plus 5? Negative 2 plus 5 is 3. So that is a true statement. So this first one works. Okay, go ahead and check the second one as well. I'm going to come over here and plug it in. So I've got 3 equals 4 times x. X is 1. And then minus 1. Does 3 equal 4 minus 1? 4 minus 1 equals 3. 3 does equal 3, so that one is true as well. So our solution to the system is 1, 3. So again, you're going to graph each line, find the intersection point, and then plug the point in to check to make sure that is your solution.